Good day, students. I am Erame Bihik, your instructor for this subject. Today, I am going to discuss to you our topic, which is trigonometric functions. But before that, I'm going to read to you the objectives for this lesson. At the end of the lesson, the students will be able to first explain the meaning of the 6 trigonometric functions. Next, determine the 6 trigonometric functions, and the last, evaluate the trigonometric functions using the formula. By the way, what is trigonometric functions? Trigonometric functions is a function of an angle or an abstract quantity used in trigonometry, including the sine, cosine, tangent, cotangent, secant, and cosecant, and their hyperbolic counterparts. Trigonometric functions are real functions which relate an angle of a right-angled triangle to ratios of two side lengths. So, this is the meaning of trigonometric functions. SOHCAHTOA. SOHCAHTOA is a helpful mnemonic for remembering the definition of the trigonometric functions sine, cosine, and tangent. SOHCAHTOA is a method used of finding the side of a right triangle. So let's proceed. The 6 trigonometric functions. First is sine. Sine is the trigonometric function that is equal to the ratio of the side opposite a given angle in a right triangle to the hypotenuse. So, the formula of sine is sine theta equals opposite over hypotenuse. So, this is the hypotenuse, which is the longest side of a right triangle, and this is the opposite. So, the formula of sine theta equals opposite over hypotenuse. This is the opposite over the hypotenuse. Next, cosine. Cosine is the trigonometric function that is equal to the ratio of the side adjacent to an acute angle in a right-angled triangle to the hypotenuse. So, this is the formula of cosine. Cosine theta equals adjacent over hypotenuse. So, this is the adjacent, the nearest side of an angle, and over the hypotenuse, which is the longest side of a right triangle. Next is tangent. Tangent is a straight line or plane that touches a curve or curved surface at a point, but if extended, does not cross it at that point. So, the formula of tangent is tangent theta equals opposite over adjacent. So, this is opposite over or divided by the adjacent, which is the nearest side of an angle. Next is cotangent. Cotangent is the ratio of the side other than the hypotenuse adjacent to a particular acute angle to the side opposite the angle. So, the formula of cotangent is cotangent theta equals side adjacent over side opposite. So, adjacent over the opposite. Next, secant. Secant is the ratio of the hypotenuse to the shorter side adjacent to an acute angle in a right-angled triangle, the reciprocal of cosine. So, secant is the reciprocal of cosine. So, the formula of secant is secant theta equals hypotenuse or the longest side of a right triangle over or divided by the adjacent, which is nearest to the angle. Next is cosecant. Cosecant is the ratio of the hypotenuse in a right-angled triangle to the side opposite an acute angle, the reciprocal of sine. So, cosecant is the reciprocal of sine. The formula is cosecant theta equals hypotenuse over the side opposite. So, this is the hypotenuse, as I have said earlier, the longest side of a right triangle over the side opposite or opposite side to the angle. So let's proceed to the first example. Solve the 6 trigonometric functions of the triangle below. So this is the figure, the right triangle ABC. So let's solve first the sine. The formula of the sine is sine theta equals opposite over hypotenuse. So, sine theta equals 9 over 15, which is the 9 is the value of the opposite or the measurement of the opposite over the hypotenuse, which is 15. And 9 over 15 can be reduced by dividing 3. That is why it is 3 over 5. So, sine equals 9 over 15 or 3 over 5 is the value of sine theta in this figure. Right triangle ABC. Next is we will find the cosine in this figure. So, the formula is cosine theta equals adjacent over the hypotenuse. So, cosine theta equals 12, which is the value of the adjacent. Let's substitute 12 over the hypotenuse, which is 15. And we will reduce it in the lowest term so that we can find the 4 over 5 by dividing 3. So, 4 over 5 is the value of cosine theta in this figure. Next is tangent. The formula of tangent is tangent theta equals opposite over adjacent. So, tangent theta equals 9 over 12, which is 9, the value of the opposite, and 12 is the value of adjacent. And it can be reduced by dividing 3's. That's why the answer is 3 over 4. So, 3 over 4 is the value of tangent theta in this figure. Next is cosecant. The formula of cosecant is cosecant equals hypotenuse over side opposite. So, cosecant theta equals 15 over 9. So, the hypotenuse is 15 and 9 is the side opposite, or 5 over 3 because we reduce it to the lowest term. So, 5 over 3 is the value of cosecant in this example or in this figure. Next is the secant. So the formula of secant is secant theta equals hypotenuse over side adjacent. So, secant theta equals 15 over 12 because 15 is hypotenuse over the side adjacent, which is 12, or 5 over 4 because we reduce it to the lowest term. Next, the cotangent. The formula of cotangent is cotangent theta equals side adjacent over the side opposite. So, for this figure, the side adjacent measures 12 and the side opposite measures 9. So, cotangent theta equals 12 over 9 or 4 over 3. So, 4 over 3 is the value of cotangent theta for this example. Next, example 2. Find the 6 trigonometric functions of the triangle below, the right triangle A, B, and C, which measures 5, for the opposite, and 12 for the adjacent, and 13 for the hypotenuse. So, let's proceed to the formula. First, we will solve the sine. Formula of the sine is sine theta equals opposite over the hypotenuse. So, since the opposite of this figure is 5, so 5 over the hypotenuse, which is 13. And since 5 over 13 can't be reduced in the lowest term, so this is the value of our sine theta in this figure. Next is the cosine. Formula of the cosine is cosine theta equals adjacent over the hypotenuse. So, cosine theta equals 12 over 13. The adjacent, which is 12 over the hypotenuse, 13. So, 12 over 13 is the value of cosine theta for this example. Next, the tangent. The formula of tangent is tangent theta equals opposite over the adjacent. So, tangent theta equals 5 over 12. The 5 for the opposite and the adjacent is 12. So, 5 over 12, since we can't reduce it to the lowest term, so this is the final answer for the tangent theta. Next, the secant. Formula, secant theta equals hypotenuse over the side adjacent. Secant theta equals 13 over 12 because the hypotenuse is 13 divided by the side adjacent, which is 12. So 13 over 12 is the value of secant theta for this example, the right triangle A, B, and C. Next is the cosecant. Cosecant theta equals hypotenuse over side opposite. Cosecant theta equals 13 over 5. The hypotenuse is 13 over 5 for the side opposite. So, the cosecant theta for this right triangle ABC is 13 over 5. Next is the cotangent. We will solve the cotangent for this figure or this example. Formula, cotangent theta equals side adjacent over the side opposite. So, cotangent theta equals 12 over 5 because the side adjacent is 12 and the opposite is 5. So, for this example, the cotangent theta is 12 over 5. Next, we will proceed to another example. This example 3. Solve the sixth trigonometric function of the right triangle x, y, and z. So, x, y, and z. So, the opposite of the right triangle x, y, and z is 15. The hypotenuse is 25 and the adjacent is 20. Let's solve the sine. The formula, sine theta equals opposite over the hypotenuse. So, sine theta equals 15 over 25 because the opposite has 15 and the hypotenuse is 25. So, 15 over 25 can be reduced. So, 15 over 25 can be reduced by dividing 5. So, the answer is 3 over 5. So, the answer is 3 over 5. So, the value of sine theta for this right triangle x, y, and z is 3 over 5. Next, the cosine theta. The formula is cosine theta equals adjacent over hypotenuse. So, cosine theta equals 20 over 25 or 4 over 5, which is 20, the value of the adjacent, and hypotenuse is the measurement of the hypotenuse. And we can reduce it by dividing 5. So 4 over 5. And the cosine and the value of cosine for this example or this right triangle XYZ is 4 over 5. Next, the tangent. The formula of tangent is tangent theta equals opposite over the adjacent. So, tangent theta equals 15 over 20. So, the value of opposite is 15 and 20 for the adjacent. So, as you can see, 15 over 20 can be reduced by dividing 5. So, the answer is 3 over 4. And the tangent theta for this figure, this example is 3 over 4. Next is secant. The formula of secant is secant theta equals hypotenuse over side adjacent. So, secant theta equals hypotenuse, which is 25, and over the side adjacent, which is 20, or 5 over 4. So, 5 over 4 is the value of secant theta for this example. Next is cosecant. The cosecant formula is cosecant theta equals hypotenuse over the side opposite. So, cosecant theta equals 25 over 15 or 5 over 3. The 25 is the hypotenuse over the side opposite, which is 15. That is why 25 over 15 or 5 over 3 because we divide it by 5. So, 5 over 3 is the value of cosecant for the right triangle X, Y, and Z. Next is cotangent. Cotangent theta equals side adjacent over the side opposite. So, cotangent theta equals 20, which is the adjacent, over the side opposite, which is 15, and divided by 5. So, the answer is 4 over 3. So, 4 over 3 is the value of cotangent theta for this example. So, this is the final answer for this example or this figure, right triangle X, Y, and Z. As you can see, sine theta equals 15 over 25 or 3 over 5. Cosine is equals to 20 over 25 or 4 over 5. The tangent is 15 over 20 or 3 over 4. The cosecant is 25 over 15 or 5 over 3. And the secant theta equals 25 over 20 or 5 over 4. And the cotangent theta equals 20 over 15 or 4 over 3. So, the sine is the reciprocal of the cosecant. 3 over 5 in cosecant, this is 5 over 3. And the cosine theta, which is 4 over 5, is the reciprocal of the secant, which is 5 over 4. And for the tangent theta, which is 3 over 4, in cotangent theta, it becomes 4 over 3. So, if you find the value of sine, cosine, and tangent theta, it is easily to find the cosecant, secant, and cotangent of a right triangle by the reciprocal of its value. So, that would be all for my discussion. Please study your lesson and thank you.